The following video was made possible by the Department of Education RISE grant. Hello, this is Professor Dr. Stefan Gramlich from the Community College of Philadelphia. And the topic that we'll be talking about is scientific notation. Scientific notation is a way of expressing numbers that are very, very large, or very, very small, in a very concise way. And so we're going to go over how to do this with some examples. You ever look into the nighttime sky and wonder, wow, there are some really bright stars? Well, you could be looking at some of the brightest stars in the sky, such as Sirius, Arcturus, Canopus, but they're not the closest. The closest star system to our solar system is Alpha Centauri, and it is 4.367 light years away, which is about 25,671,408,700,000 miles away. That is an astronomical number, pun intended. We can try to express that in scientific notation, or we can even make it even more concise by rounding off to the 10th spot and just merely saying 2.6 times 10 to the 13th miles away. In the last example, we saw 2.6 times 10 to the 13th power with scientific notation. So let's go over the methodology from converting from standard notation to scientific notation. Well, scientific notation involves a number which we'll call a, which is a natural number between 0 and 10, and it has to go to the left of the decimal point. And so what we want to do is we want to move the decimal point when it's in standard notation to the right of the first non-zero digit. In this case, we'll call it a. And then you want to put the other numbers after the decimal point that follow, multiplication symbol, and then multiply it by a base of 10 with an exponent that we'll call n that is either positive or negative. Now, if you're talking about a very large number, n is going to be positive. If you're talking about a very small number, n will be negative. So as another example, let's take Avogadro's number, which was a number that Italian scientist Avogadro came up with back in the early 19th century, which actually was the amount of atoms in 12 grams of carbon. Now, it's a unit of measurement. It's kind of like a dozen eggs, which means that there's 12 eggs. Well, a mole would represent 6.02214 times 10 to the 23rd. Now, this is going to be a huge number because we know the n is going to be positive 23. And you can see here in the little diagram that if you were to move the decimal point 23 times to the right, you are going to get a huge number. And so Avogadro's number is indeed a very, very large number. Again, the kind of number you probably want in your bank account. Well, let's look at an example where we have a very, very small number. Let's take paramecium protozoans, which are single-celled microscopic organisms that feed primarily on yummy bacteria. Blah. Well, let's have an example where we are looking through a microscope and we happen to view a paramecium protozoan that's 275 micrometers long, which is about 0.000275 meters. Really, really small number. So we can express that in scientific notation if we take the decimal point and move it 4 times to the right of the non-zero digit 2, which is the first non-zero digit read from left to right. We would get 2.75 times 10 to the negative 4. Now, why is the exponent negative? Because we're talking about very small numbers, so negative 4. So that will conclude our presentation. I hope it was fun, enlightening, and helpful to you.